Tomorrow we cover 4.4. I don't want to spend any more time than today on 4.3. This is all stuff you guys had last year. You had 4.1 last year, you had 4.2, you had 4.3, you even had 4.4. 4.4 is going to be more difficult. I'd like to spend more time on that. This is stuff you know how to do. If you do it right now, and I even got my daughter trained in this manner, if you do your homework tonight, that will convert to your long-term memory. The other day I was telling my daughter about how, I put something off, and she looked at me, and she's 7 years old. She said, "Daddy, you won't remember it for very long then." I said, "Yeah, very, very good." She's like, "You need to do it right away, and you need to sleep at night." That's right. I was telling her in college I used to sleep about 4.5 hours a night, and she's like, "Well, Daddy, that didn't really work well for your long-term memory." Yeah, very, very good, Kira. Very good. All right, you got it. Thank you. She's like, "You didn't remember stuff very." I said, "No, I didn't. I remembered it right away, but then it was gone after that." So do your homework tonight, sleep well, and this will work well for you. Here's what you need to do. Log base A of A times B is the same thing as log of base A of A plus log base A of B. This is true. You can separate the product into a sum. Now you may be asking yourself, why on earth can we do that? I'll show you. It'll make sense now. Remember, logarithms are about solving for exponents, right? Watch this. I'm multiplying. What's the base? The base is the same, right? The base is the same, A and A. What do you do to the exponents? You add them. When you're multiplying, you add the exponents. You add the exponents. That's all we're doing, is we're rewriting logarithms in that way. So that's the connection that you need to make here. If you're dividing them, what do you do to the exponents? You subtract. So you got log base A of A minus log base A of B. Key is it has to have the same base. And finally, log base A of A to the C. If I had x to the third all to the 7th power, if you take a power to a power, what do? You multiply. And so if I multiply, then I will take the C and I will multiply the log by that C. So here you can actually take this C and move it out front, just like so. You remember these somewhat from last year? Some of you do, some of you don't. You must not have slept and done your homework. All right. Use the laws of logarithms to rewrite the expression in a form with no logarithm of a product, of a quotient, of a root, or a power. Often when people get to the section, they ask Mr. Gens, they say, "Mr. Gens, when am I done?" And I say, when you do not have a product, a quotient, a root, or a power. That's when. The directions say that. Right now, I have a product, 5 times 3. I want to separate it using my laws of logarithms. How can I rewrite this? Log of 5 plus log of 3. Good. Now, somebody, second hour, said, "Isn't that just the log of 8? No, it isn't. It's the log of 15. Remember, you multiply them together. They wanted to go forward then. We just went backwards. We took it apart. If you want to bring it forwards, it's the log of 15. A for the day. What's the base of this logarithm? 10. Very good. All right, this one's a little bit different. I have multiplication. I also have powers. So I'm going to separate it like this. Log of 3 plus log of 4 squared plus log of 5 to the 6th. Does everybody see how I did that first step? What do you want to do next? Good. Yeah, put the 2 in front of the log and put the 6 in front of the log, right? So now that I've done that first step, now I can bring the exponents out front. And I now have the log of 3 plus 2 log of 4 plus 6 log of 5. So now you know, I don't have a product. I don't have a power, right? So I'm good. You want to try C on your own? Second hour got scared. They didn't think they could do it. Why don't you give it, you know, take a minute, see if you can get started on it. I'll help you out here in a second. Try C on your own. You can do it because you're super smart. Super smart. Here you go. You must have one of these two. One of these two would be correct. It's either 3 times the log of 4 minus log of 7 or 3 times the log of 4 minus 3 log of 7. You could write the 3 as in parentheses out front or distribute it through. Either way would be fine. How many got it right? Oh, all right. Good job. Any questions how I did that? Any questions? All right. This one I should rewrite. I should rewrite this, and so I'm right. You know, you guys got the idea now. If you got that one, now it's just about showing you some of the tricks of the trade, and that would be log base 3 of x squared minus 5, all to the 1/2 power. So instead of writing it as a square root, I'm going to write to the half power. That's an easier way to understand it. What's the first step? What do you want to do? Put the 1/2 out front. 1/2 times the log base 3 of x squared minus 5. In our laws of logarithms, was there a way to separate addition or subtraction? No, there wasn't. If you look, we have a way to separate multiplication, we have a way to separate division, and we have a way to separate powers. But we do not have a way to separate addition or subtraction. So this x squared minus 5 just stays. I can't do anything with it. The 1/2 is out in front. That's all I can do. Done. You're supposed to say, wow, Mr. Gens, that's amazing. This is so much fun. May I please have more logarithm problems? Well, sure you can, Sarah. Let's do some more logarithm problems. All right, how about this one? These last two are kind of fun. They take a number of steps, 3, 4, 5, 6 steps. What's the first step for letter E? What do you want to do first? Natural log of 2x to the 4th. Good. Minus the natural log of what? X minus 2 to the 3rd. Good. Okay, let's just pause. Let's look at what we got here. Do you have multiplication here? Yeah, you do. You got 2 times x to the 4th. Got multiplication, and we have to separate that. You got powers? Is it x to the 4th, or is it 2 to the 4th, or is it both? It's just x to the 4th. So I will only bring the 4 out in front of the x part. Here I've got this power part, so that's going to come in front of there eventually. So let's, I'll make one step here. I'm going to separate this multiplication piece into natural log of 2 plus the natural log of x to the 4th minus 3 natural log of x minus 2. Everybody okay with that? Now, what's my last step? Bring this 4 out in front. A lot of people second hour didn't like this separating the 2 and the x to the 4th, but you got to do that. So we've got natural log of 2 plus 4 natural log of x minus 3 natural log of x minus dos. Dos is Spanish for 2. Ah! Lucas, oh, Lucas is reading. You didn't hear that. You know what Sarah just said? I don't like the natural log. I think they should write it in cursive. What do you think they said second hour? What do you think they said last year? You're all the same. So then I said, okay, so how about I write it like that? They're like, no, don't write the N in cursive, just write the L in cursive. Oh, all right, well, fine. So, no, I'm not going to do that. Natural log. How about that? Now you want that? And then I sign my name for them. Well, that's what they said. What do you mean an R? That's an I. You look like an R. That is my dot. My real signature looks like this. That's my signature. When I sign it, done. There you go. Now Chrissy's going to forge my signature. I will not write in cursive. I will not give in to the peer pressure. I'm done with you and your demands, Savvy. Yeah, you take your suggestions and tell them to Riz, and you look kind of girly. All right. Natural log of 4x squared over 2yz to the 1/3 power. Before we even start, what's all the stuff you see? A 3. I got division here, so I'm going to separate that into subtraction. I got multiplication on top with a power. I've got multiplication on the bottom twice, and then I got a power on the outside. Oh my gosh. What do you want to do first? No. No. Let's do the 1/3. We will put the 1/3 out front times the natural log of 4x squared over 2yz. Now, if you wanted to attach that 1/3, using your properties of powers to the 4 and the x squared and the 2 and the y and the z, then fine. You could do that and then, then go from there. But I just think it's easier to just put the 1/3 out front right away. Now we have, let's see, we have multiplication, we got powers, we got division. Which one should I attack first? Division, very good. So I've got 1/3 times the natural log. Whoop. 1/3 times the entire piece, right? That's where last year messed up. Was when do we put that parenthesis out in front? Well, if you're going to separate in two pieces here, the 1/3's got to be multiplied all the way through. So I've got the natural log of 4x squared minus the natural log of 2yz. What you think about that? What? What'd you say? Billy, what do you want to do? Yeah. Yeah, now Bailey wants to separate the 4. Yeah, you want to separate the 4 and the x squared, right? Yes, that's what we do. 1/3 times the entire piece, natural log of 4, plus natural log of x squared. Now, watch this. Am I subtracting just the natural log of 2, or am I subtracting all of it? All of it. So I got to go minus, parentheses, natural log of 2, plus natural log of y, plus natural log of z. Yes? Should we distribute our negative through? Let's do that. So all we have to do now is we distribute our negative through, and what else? What's the last step? Yeah, so I'm going to put the 2 out front. I'm going to distribute this negative all the way through. Let's do that. 1/3 times parentheses, natural log of 4 plus 2 natural log of x minus natural log of 2. Oh boy. Minus natural log of y minus natural log of z. Prince. Now there is just one more small thing, you guys. And just watch this. I would accept this on test, but watch right away. What's 4 divided by 2? So you should simplify right away. But I wanted to show you that if you get this far, watch. The natural log of 4 minus the natural log of 2. What's the natural log of 4 minus the natural log of 2? That's the natural log of 4 divided by 2, right? Which is the natural log of 2. So technically, you should simplify in this situation and just get 1/3 times natural log of 2 plus 2 natural log of x. This is gone, minus natural log of y minus natural log of z. Technically, that's what you should do. So what I did is I combined terms that I could. I was able to combine that and that. I didn't subtract 4 and 2. I divided 4 and 2. I think you see that. So we could have taken care of that right away and we wouldn't have had to do that had we divided the 4 and the 2 right away. And that's what we should have done. I could scroll it down. So we've taken them apart. Now let's put them together. Flip it on over. Do. We got the whole back side. Log base 2 of 5 plus log base 2 of 7. Make it into 1. Good. Log base 2 of 5 times 7. What's 5 times 7? Good. Log base 2 of 35. Good. That's it. I'm going to encourage you to rewrite problem B. I would rewrite it like that. 2 log base 5 of 3 minus 1/3 log base 5 of 64. Do you see why I wrote it as 1/3? Instead of dividing by 3, I want the 1/3. Now, what's the first step? What do you guys want to do? Andy, what do you want to do? Good. What is 3 to the second power? 9. So you got the log base 5 of 9. And then what's 64 to the 1/3 power? What's the cubed root of 64? 4. Good. So you've got log base 5 of 9 minus log base 5 of 4. Instead of writing as subtraction, I can write them as 1 using division. So you got the log base 5 of 9/4. It's good. So this whole expression that you see for B actually simplifies to this. It's kind of cool. It's really cool. How about C? What do you want to do? Okay, let's do our exponents first. Bring the 2 up there, bring the 3 up there, bring the 1/2 right there. So, what's 4 squared? So you got the natural log of 16 minus, what's 2 to the third? Natural log of 8 plus natural log of square root of 2. I got subtraction. I've got multiplication. Or I'm sorry, I got subtraction and addition, so that means I'm going to write it using division and using multiplication, right? So that'll be the natural log of what? (16) divided by 8. Now, is it times the square root of 2 on the top, or is it times square root of 2 on the bottom? Well, we could simplify it. Does it intend to be on the top or the bottom? Top. The question is why? Everybody watch this. This is super important. Super important that you don't miss this. Okay? If I had parentheses here, then it's subtracting everything, and the square root of 2 would be on the bottom, right? But I don't have parentheses, and so you could have just as easily wrote it like this: natural log of 16 plus the natural log of the square root of 2 minus natural log of 8. I mean, you can rewrite that to look like that. And so you got 16 times square root of 2 divided by 8. What's 16 divided by 8? 2. That's the answer. That's the answer. You're smart. Tara, if you were on Who Wants to Be a Millionaire, and you had a lifeline, and you could call one person in this room, who would you call? You call Alex. You want to call me? Oh my goodness. Well, this is a good question. This is important. I want to cut of the $1 million, and if I answer the question right, then I might get something. Yes, they do. Okay, what kind of questions do they ask? Okay, who is the third president of the United States? Alex Yonke. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. No! Thomas Jefferson! You guys are horrible! Holy cow! You all fail! Oh, you want some choices? Oh my gosh. Who was the 16th president of the United States? Lincoln, very good. Oh, can I tell you a sad story real quick? Raise your hand if you went to see Lincoln. Okay, I want to see it. I'm sure it was awesome. The Lakers, if you know the team, the LA Lakers, they haven't been playing very well lately at all. And for a team bonding experience, they decided to go see a movie together. They went and saw Lincoln. This was a while ago. And a number of the players on the team were surprised. They didn't realize that Lincoln got shot. I'm not kidding. I am not kidding. Welcome to your society, folks. That's the type of education going around the world. Well, what are you guys laughing at? You didn't even know who the third president of the United States was. Come on. Nobody said Robin Victoria. All right, here we go. 3 times natural log of x plus 1 plus natural log of x plus 2 minus 2 natural log of y. What do you want to do with first? What do you want to do with first? Good. Inside stuff. We should take that times that and divide it by that, right? Very good. So we have the 3 on the outside times the natural log of, what's x plus 1 times x plus 2? X squared plus 3x plus 2 over y squared. Right? Questions how I got that? I skipped a couple steps. I multiply these two because there's plus, and I divide by this. And this is y squared because you got to move the 2 up to the exponent. Right. Now what should I do with that 3? Yeah, 3 comes up here in front of everything. So you can write it as, you got 2 options. Natural log of x squared plus 3x plus 2 over y squared all to the 3rd power. Or you could write it as the natural log of x squared plus 3x plus 2 to the 3rd power over y to the 6th. Either way is fine. I don't care which way you do it. But if you were to just write it like this, say not y6 on bottom, y squared, no, that's not correct because the 3, this just shows the 3rd power going to the top. It has to go the whole thing. So that would be incorrect. Okay? Question. Oh, you want the etymology behind... Shouldn't it be NL? So, how about this? I give you a full explanation tomorrow. Etymology. Edamama? That's Edda's mama. I don't know who Edda is. But it's her mama, so, alright. Okay, evaluate the following expression. Flip your notes over to the very last page. We're almost done here, folks. I want to show you the important laws that you've learned so far. Number 1, the basic definition of a logarithm. Okay? Log base a of x equals y means a to the y is equal to x. That's what it means. Natural logarithm, that's what we just talked about with Alex. Natural log of x is log base e of x. We talked about basic properties of logs and natural logs. Right now, we just did these laws right here. So this whole sheet has summarized many of the formulas that you've talked about. We're going to do change of base today, but this is the one right now I want you guys to focus on, right here. Log base a of a to the x is an inverse operation. We talked about that yesterday, and you're just left with the x. A to the log base a cancels off, and you're just left with the x. Natural log and e cancel out, leaving you with just x. E to the natural log leaves you with just x. So understand those are inverse operations, and that's going to come in very, very, very helpful. Let's go back to our page, and let's simplify some of these things. Evaluate the following expression. Watch how I do this. We have as follows. Log base 2 of 32 to the 1/2 power. Everybody agree that that's okay? All right. Now I'm going to do one more step here. Log base 2 of 32 can be written as 2 to the 5th, right? Yes, no? What do I do with exponents? Exponent to exponent, what do I do? Multiply them. So that's log base 2 of 2 to the 5 halves. Okay? Now look at what you have here. Log base 2 of 2 to the 5 halves. What cancels off? Good. So this cancels off and just leaves you with 5 halves. That's the answer. If you were to actually evaluate this on your calculator, you would get 5 halves. Sometimes you need to simplify using other laws before you do it. Instead of doing subtraction, what can I do? Log base 5 of 100 divided by 4. What's 100 divided by 4? 25. Would you agree that 25 is 5 squared? What cancels off? Leaves you with just 2. 2 is the answer. Log base 3 of 27 to the 4th power. I'm going to rewrite it as log base 3 of 3 to the 3rd to the 4th power. What do you do with an exponent to an exponent? Log base 3 of 3 to the 12th. What cancels off? What's that? You like that? They're inverse operations. The log with a base removes the base and leaves you just 12. Here, what can I do with this 3? So I have e to the natural log of 5 to the 3rd. What's the base of natural log? What cancels off? Leaving you with 5 to the 3rd. So we have to be used to using those exponents. Hold on one second here. That on YouTube. Okay, all right, okay. All right, last thing. This is nice and easy, okay? Change of base formula. Use the change of base formula and a calculator to evaluate the logarithm to 6 decimal places. Here's the deal. If you go to your last page, and this is going to go really quick, but this is one of the most important parts of today. You're going to use this all of the time. All of the time. On your calculator, you don't have a log base 2 button on your calculator. You don't. You have a log base 10, and you have a natural log base e. So that's what you have. But if you want to evaluate log base 2 of 6, that means 2 to what power is equal to 6? Well, I know it's more than 2, and I know it's less than 3, but what is it exactly? The way that we evaluate that is we use this formula. And what this formula basically says is this. You take the log with any base, so we would choose 10 or e, of that number divided by log with whatever base we want, 10, of the bottom number. That's all we do. So if you go back to your notes, we'll do those 3 problems. Log base 6 of 14. You have 2 options. What is currently the base? I could change it to a base of 10 and do the log of 14 divided by the log of 6. Or you could change the base to e and do natural log of 14 over natural log of 6. In fact, you could choose to change it to a base of 113. The question is, Why would I not choose 113? That button is not on my calculator. I have these two buttons on my calculator. So I take out my calculator. This side of the room, do log. That side of the room, do natural log. See what you come up with. This side of the room, do log. That side of the room, do natural log. When you get an answer, let me know. Shh. What did you guys get? You see you get the same thing. It doesn't matter. Yeah. So what does that mean? That means 6 to the 1.47 power is equal to 14. Same thing here. If you want to evaluate log base 7 of 2, you don't have base 7 on your calculator. So you change it. I'm going to do natural log of 2 divided by natural log of 7. Natural log of 2 divided by natural log of 7. 0.356. Now again, what that means is 7 to the 0.356 power is equal to 2. That's what that means. And finally, the last one, again, if you want to choose base 10, log base 10 of 1,652 divided by log base 10 of 14. .808. And that's it. Here's your assignment. Now, they look like there's a lot of work to them. They're not. We went through these pretty quickly. But do dedicate yourself to doing some homework tonight. On the way to Mankato, do your homework with Anna Anderson. Do your homework on the way home. I do remember very well being a 3-sport athlete and needing to do my homework on the bus. Working on one problem, the boardwalk problem. I remember that. Oh, and this says Greta hates mathematics. So next time you see Greta, not a very nice person, is she? All right, everybody, have a good night.